Good morning, guys. So today we will discuss solving an exponential equation. So if you want to solve exponential equation, let's say you have 3 to the power, you have to solve 3 to the power 2x minus 1 equals to 0.4 raised to the power x plus 2. So we want to solve this exponential equation. Okay, so remember last time we discussed if you have x equal to y, right, then you can take logarithm on both sides. So logarithm of x with base a. So logarithm with base a of x equals to log a logarithm with base a of y. We know that, right? So, and remember, like generally if you have the base a is e, so you'll have a log e x equal to log e y. And this log e is the ln, right? So this is, you know that, like logarithm with base e is ln. So ln x equal to what? Ln y. So if you have x equal to y, so you can take natural log ln on both sides, right? Or if you replace this a by 10, so you'll have a logarithm with base 10 of x equal to logarithm with base 10 of y. And you guys know that logarithm with base 10, this is the common log. So you simply write down log x equal to what? Log y. So if you have x equal to y, that is also equivalent with what? Log x equal to what? Log y. Right? So the idea here is you can either take natural log on both sides or common log on both sides. It's up to you. So I want to take natural log on both sides, okay? So if I take natural log on both sides, it's going to be ln 3 to the power 2x minus 1 equals to ln 0.4 to the power what? X plus 2. Is that right? And then remember the property of the power property of logarithm. Remember, if you have a logarithm with base a x to the power r, this is same as r times logarithm with base a of x. So now here also, if you apply this property, you can write this. You can rewrite this as 2x minus 1 times ln 3 equals to x plus 2 times what? Ln 4. Sorry, 0.4. So this is ln 0.4. You got it? So you need to find the value of x. So you distribute this ln 3, so it's going to be 2 ln 3x, or we can write like this, okay, 2x times ln 3, 2x times ln 3 minus ln 3 times 1 is ln 3, and this ln 0.4 times x is x times ln 0.4 plus 2 times ln 0.4. Did you see that? Did you get it? I distributed this. Ln 3 times 2x is this. Ln 3 times 1 is this. And ln 0.4 times x is x times ln 0.4. Ln 0.4 times 2 is 2 ln 0.4. Right? And then you group x terms. Okay, so let me move this to the right side. So you add ln 3 on both sides. And you subtract x ln 0.4. So you cancel that and you cancel that. So now what do you have? On the left side, you have a 2x ln 3 minus x ln 0.4 equals to, on the right side, you have a 2 ln 0.4 plus ln 3. You got it? And then you factor out x from here. So if you factor out x, so it's going to be, you factor out x, okay, from here. So that will be 2 ln 3 minus ln 0.4 equals to 2 ln 0.4 plus ln 3. So you divide both sides by what? So you have to isolate x, right? If you want to isolate x, you divide both sides by 2 ln 3 minus ln 0.4, and you divide both sides by 2 ln 3 minus ln 0.4. So you cross them out. So what will be the value of x? So the value of x will be equal to 2 ln 0.4 plus ln 3 over 2 ln 3 minus ln 0.4. So now you have to use calculator, okay? So can you find out what is the value of this right hand side? You use the calculator, okay? So let me use that one, okay? 2 ln 0.4 plus ln 3. So that will be on the numerator. What did you get? I got on the numerator, I got negative 0.7339691,751. Did you get the same? And in the denominator, you have a 2 ln 3 minus ln 0.4. So that will be 3.113515,309. So x equal to, you divide negative 0.7339691,751 by this, okay? So we got x equal to negative 0.23573,64915. Okay. So you round to nearest thousands. So this is 10th, 100th, 1000th. So it's going to be x equal to negative 0.23. You see the digit after the 1000th place is 7, right? So which is greater than 5. So it will go up. So x equal to negative 0.236. Does that make sense? Yes? Okay. So, yeah. I think we got it right. Let me check that. Yeah, negative 0.236. Make sense? Okay. So now one thing is, if you have a exponential equation, like this e to the power x squared equal to 200, you take natural log on both sides. So okay, if you have a to the power x square equals to 200, right? So you want to solve this equation, okay? So one thing you need to know is, if you have a natural log a to the power x, because remember that natural log is logarithm with base e, right? So logarithm with base e to the power x, this is equal to what? X. Note that, okay? So this is, if you have a ln into the power x, that will be equal to what? X. So if you have a equation with base e, exponential equation, right? Take natural log on both sides. Do not take common log. It will be easier for you take natural log. So you take natural log ln on both sides. So that will give you ln e to the power x square equals to ln 200. Right? And use this property, okay? You know why, right? This is this, okay? ln e to the power x, you use the power property. So you can pull out this x right in front of ln. So this is ln e. And remember, if you have a logarithm with base a of a, this is always equal to 1. So this ln e is the log with base e of e. So this is equal to what? X times 1 equal to what? X. Did you see that? Just keep in mind, okay, ln e to the power x is x. So now here, if you have a ln e to the power x square, then obviously it's going to be what? What will be this? If ln e to the power x is x, exactly, x squared equal to what? ln 200. Right? And use the square root property. Remember the square root property, if you have x squared equal to, if x squared equal to k, so this is x equal to plus or minus radical k. So this is the square root property, right? So if you use that, what will you get? You will get x equal to plus or minus radical ln 200. And use calculator to find the value of radical ln 200. So this is going to be x equal to, so round to the nearest thousandth, okay? So you see x equal to plus or minus 2.301807413. So if you round to nearest thousand, so x equal to plus or minus 2.10 hundred thousandths. You have a 1 in the thousandth place. Is that right? And look at the digit after 1, 8, which is greater than 5. So you have to move it up. Right? So 302. So the solution is this. Does that make sense? So the solution is, you can write down like this, negative 2.302, comma 2.302. This. You got it? Yes? Good. So I think this is multiplication here, okay? I believe so. Yeah, this is. Yep, this is multiplication. you have e to the power 2x plus 1 times e to the power negative 4x equals to what? 3 times e. So you have to solve this exponential equation. Remember the property of law of exponents? If you have a to the power m times a to the power n, it will be a to the power m plus n. Right? So e to the power 2x plus 1 times e to the power negative 4x is e to the power 2x plus 1 plus negative 4x equals to 3 times e. Make sense? So it will be e to the power 2x plus 1 minus 4x equals to 3 times e. So this is e to the power, what is 2x minus 4x? Negative 2x, right? Plus 1 equals to what? 3 times e. Make sense? So now you can divide both sides by e. You can divide both sides by e, or you can take ln on both sides, okay? That's good. Take natural log on both sides. So this is ln e to the power negative 2x plus 1 equal to ln 3e. Right? And then use power property. So this is same as negative 2x plus 1 times ln e equals to ln 3e. Use the product property. You remember the product property? The product property is if you have a logarithm with base a of, let's say, m times n, it's same as, right, the logarithm with base a of m plus logarithm with base a of n. So if you use this property here, you'll have a ln 3 plus ln e. Make sense so far? And then, what is the value of ln e? What is the value of ln e? Remember, ln e to the power x is x, right? So what is ln e to the power 1? So ln e is ln e to the power 1, which is what? 1. So negative 2x plus 1 equals to ln 3 plus 1. So far so good. And then you subtract 1 from both sides. You cross them out, so that will be negative 2x equal to what? ln 3. So you divide both sides by negative 2. You have a negative 2. Cross them out. So x equal to negative ln 3 over 2. Right? And what is negative ln 3 over 2? So negative ln 3 over 2. So I got negative x equal to negative x equal to negative 0.54930614443. And you round to the nearest thousandth, okay? So if you round to the nearest thousandth, round to the nearest thousandth. So you'll have x equal to negative 0. Now if you round to the nearest thousand, you see this will be, this is in the thousandth place, right? So you have a digit 3 which is less than 5, right? So you simply have x equal to negative 0.549. The solution is negative 0.549. You got it? Okay. So now similarly, by the way, for this one, you have to replace, look here. So this is so you have e to the power 2x minus 4 times e to the power x plus 3 equal to 0. Right? So remember, this is same as this e to the power 2x is same as e to the power x raised to the power 2 minus 4 times e to the power x plus 3 equal to 0. So you put e to the power x equal to, let's say, a. Right? So this is going to be a square minus 4a plus 3 equal to 0. Now this is a quadratic equation. Right? So how do you factor? What are the factors of this quadratic equation? What are the factors? A minus 3 times a minus 1 equal to 0. Right? And use zero product property, okay? So if you use zero product property, then you'll have a minus 3 equal to 0, or either a minus 3 equal to 0 or a minus 1 equal to 0. So a minus 3 equal to 0, that will give you a equal to 3, or a minus 1 equal to 0, that will give you a equal to 1. But what is a? A is e to the power x. So you return back the value of a, so e to the power x equal to 3 or e to the power x equal to 1. Take natural log on both sides, so you have ln e to the power x equal to ln 3. So what is ln e to the power x? Ln e to the power x is x, right? So x equal to ln 3. So e to the power x equal to 1. So ln e to the power x equal to ln 1. Make sense? And this is ln e to the power x is x. So this is ln 1 is, what is ln 1? 0. So the value of x is either 0 or ln 3. Did you get it? Right? Yeah. That makes sense. Okay. Now similarly, if you have a logarithmic equation like this, so you have a logarithmic equation like logarithm with base 2 x cubed minus 19 equal to what? 3. So you have to solve this equation. Do you know how to solve it? Remember the logarithmic and the exponential form, like you see, what is the, if you have a logarithm with base a of x equal to y, this is equivalent. This is the logarithmic form. The equivalent exponential form for this is x equals to a to the power y. Right? So now you have, what do you have here? Logarithm with base 2 x cubed minus 19 equals to what? 3. So this is equivalent with x cubed minus 19 equals to, hey, look here, in place of x, you have x cubed minus 19. In place of a, you have what? 2, right? You have a here and the 2 here. So 2 to the power, what is the value of y? What is y? 3. Did you get it? And so this is x cubed minus 19 equals to 8. So you add 19 on both sides, plus 19, you cross them out. So that will give you x cubed equals to 8 plus 19 is what? 27. If x cubed equal to 27, so that will give you x equal to 3. So the solution is 3. Okay? And for this type of equation, you have to have a logarithm with logarithm of x plus 6 minus log x plus 2 equals to log x. So you have to solve this. So how do you solve this? So remember the quotient property, okay? If you have a logarithm m over n, logarithm with base a of m over n is same as logarithm with base a of m minus logarithm with base a of n. Is that right? So use this property, okay? Now here you have log x plus 6 minus log x plus 2. So this is equivalent with what? Log x plus 6 over x plus 2. Right? So this is, the left-hand side is equivalent to what? This. So if you look here, this one is same as log x plus 6 over x plus 2 equal to log x. And then remember, we have, if you have x equal to y, this is same as, this is equivalent with what? Log x equal to log y. Right? So If you have a log x plus 6 over x plus 2 equal to log x, so this is equivalent with what? X plus 6 over x plus 2 equal to x. So you see you have a x plus 6 over x plus 2 equal to x. It has over 1. You cross multiply. You cross multiply, so x plus 6 equal to x times x plus 2. Make sense? And then this is same as x plus 6 equal to, you distribute this. X squared plus 2x. So you subtract x, and subtract 6, you cancel that, right? So 0 equal to x squared plus 2x minus x is x minus 6. So you'll have x squared plus x minus 6 equal to 0. Make sense? And then you factor this. So what would you get if you factor this? X squared plus x minus 6. What are the factors of x squared plus x minus 6? It will be x plus 3 times x minus 2 equal to 0. Right? So use zero factor property. Either x plus 3 equal to 0 or x minus 2 equal to 0. So that will give you x equal to negative 3 and x equal to 2. But you got to be very, very careful here, okay? If you plug in the value of x equal to negative 3 in the original equation, right? So you'll have, if you plug in x equal to negative 3 here in the original equation, look here. So you have a log 6 minus 3 is 3 minus log x is negative 3 plus 2 is negative 1. Is that right? Equal to log negative 3. So now, right. So log negative 1 and log negative 3. You know the domain of the logarithmic function, right? So which is positive number. Yes, positive number, right? Greater than 0, right? But here you see negative 1 is the input, negative 3 is the input. So these two are undefined. Makes sense? Right? So that's why this negative 3 is not a solution. So this is not a solution. X equal to negative 3 is not a solution. Make sense? But 2 is good because if you plug in 2, you get a positive number here, positive and positive. So that's why the solution is 2. You got it, guys? You know what? You see, this negative 3 is not in the domain of log. The domain of logarithmic function is what? All positive real numbers. So I think we talked like most of the problems here, right? So let me go to the next section. Excuse me. So now we will discuss applications and models of exponential growth and exponential decay. So you can read this, okay? So in biology, economics, and ecology, the quantity change at a rate proportional to the amount present. So in such a case, right, in such cases, the amount present at time t is a special function of t and called exponential growth and exponential decay. So generally we model the amount present at time t. So this is yt. This is the amount present at time t. This is the initial amount y sub 0 and e to the power kt. So this is the model. If k is positive, it will be exponential growth. If k is positive here, so that will be exponential growth. And if k is negative, so that will be exponential decay. Make sense? So this is the initial amount, okay? Or you can say the amount at the time t equal to 0. So this is the amount present at time t. Yt is the amount present at time t. Y0 is the amount present at the beginning, at the time t equal to 0, or the initial amount. And this E is the exponential number, t is time, and k is constant. If k is positive, exponential growth. If k is negative, exponential decay. Make sense, guys? Yeah. Did you get it? Let y0 be the amount or number present at time t equal to 0. Then under certain conditions, the amount present at any time t is modeled by y equal to y sub 0 e to the power kd, where k is a constant. Good? Good. Okay. So now, and I told you when k is positive, the growth function. When k is negative, it will be decay function. So look here, guys, like in this problem, you see, can you read this? You see the carbon dioxide over the growth of carbon dioxide over time using a function based on the data from the table. Now we determine such a function from the data. So you have to find out exponential function that gives the amount of carbon dioxide y in year x. Okay. So how do you do that? $375. Yeah. Use the model, like if you look at this model, Look here, yt equal to y sub 0 e to the, the question is you have to find the exponential, models for this function, Find an exponential function that gives the amount of carbon dioxide y in year x. So go to the table and use this model, guys. Use this. So let's say the initial amount of carbon dioxide, okay, is 353, okay? So remember in the table you see you have a year here and then you have a carbon dioxide, in the year 1990 you have a carbon dioxide 353. So that means your initial amount, we have a yt equals to, your initial amount is 353, right? E to the power kT. So this is your initial amount. You see the table, you remember that 200 is 375, you have this, and this is 2000. So you have a 2075 equals to 590, and you have a 2175, is that 1090, and in 2275 you have a what? 2000, right? So this is in the table, right? So this is your initial amount. So this is the value of y sub 0. Make sense? And now look here. So you have a carbon dioxide 2000 ppm when in year what? In year 20 to 75, right? So that means after how many years? So this is your initial. We consider this as initial, right? So after how many years the amount of carbon dioxide, it will be 2000 ppm. So you subtract 1990 from 2275. What? 285. Exactly. After 285, because we consider this as what? Initial amount, right? So after 285 years, the amount of carbon dioxide will be 2000 ppm. Are you with me? Because when you subtract you subtract 1990 from 2275, that will give you 285. Is that what you said? Yes, right? So that means T equals to 285. After 285 years, how much will be the carbon dioxide? So Y equals to, you can write Y 285 equals to 2000. Makes sense? So you plug in 2000 for this one. So this is 2000, and the initial amount y sub 0 is, what is the initial amount? Initial amount is 353, right? We have this 353, and e to the power k, and what is the value of t? 285. And you solve this equation and get the value of k. And plug in back the value of k, you will get the exponential model. That make sense? Okay. So now, hey, divide both sides by 353, okay, 353. So divide both sides by 353. Now here you have a 353. You cross them out. So you will have 2000 over 353. You can write here 2000 over 353 equals to a to the power 285 k. Okay? So this is an exponential equation, so you take natural log on both sides. So if you take natural log on both sides, you'll have ln 2000 over 353 equals to ln a to the power 285 k. So this is same as ln 2000 over 353 equals to, and remember that ln e to the power x equal to x. Right? So ln e to the power 285k is 285k. Make sense? So you divide both sides by 285, okay? Cross them out. See that? So this is same as 1 over 285 ln 2000 over 353 equals to k. So now simplify this, okay? So ln 2000 divided by 353, and you divide that by 285, okay? So I got this is exactly, I got this number, okay? This is this is ln 2000 over 353 is 1.734434403 over 285 equal to k. Divide by 285, so I got k equals to 0.0060857347. This is the value of k, and you have to return this value of k. You have to plug in the value of k here, okay, to get the solution, okay? Yep, 0. If you round to 5 decimal places, this is gonna be k equal to, this is k equal to k equal to 0.00609. 1, 2, 3, 4, 5. Yeah. So now you plug in back the value of k. You plug in back the value of k here. So you'll have yt equals to 353 times e to the power 0.00609 t. So this is the model we have. Did you get it? Yep. So this is one thing we have to do, and the next one is estimate the year when the future level of carbon dioxide will be double the pre-industrial level of, what do you have, the pre-industrial level of 280 ppm. So you have to find out the year when the future level of carbon dioxide will be double the pre-industrial level of 280 ppm. So what is the double of 280? So this is our model, right? So estimate the year when the future level of carbon dioxide will be double the pre-industrial level of 280. So you guys know that double of 280. Exactly. So double of 280 is 560. So you plug in yt equal to what? 560. And solve for t. So that will give you the what? Year. That makes sense? So now if you plug in 560 here, this 560 equals to 353 times e to the power 0.00609 t. Good. You divide both sides by 353. You divide both sides by 353, so 353, 353, you cross them out, so you have 560 over 353 equals to e to the power 0.00609 t. And again, take ln on both sides, okay? So you take ln on both sides. Then what do you have? ln 560 over 353 equals to ln e to the power 0.00609 t. Right? So this is ln 560 over 353. You see the ln e to the power x equal to x. So ln e to the power this equal to what? 0.00609 t. Make sense? And then you divide both sides by 0.00609. You divide both sides by 0.00609. You cross them out. So the value of t will be, you use the calculator to evaluate this, okay? So you have a ln 560 divided by 353 is this, right? And so they divide that by 0.00609. So that will give me 75.77. Yeah. So I got t equal to 75.77. That makes sense? But you see, so in what year? So you have to estimate the year, right? So this is the model after t years. And remember this 353 ppm, this is the amount of carbon dioxide in 1990. Is that right? If you go back to the table, you can see that. Yeah. Look here. So if you go back to the table, so 353 is the amount of carbon dioxide in the year 1990. Is that right? So if you consider x equal to 0 correspond with 1990, so you add this, okay, with 1990. So 1990 plus 75.77. What is that? 1993 plus 75 point. So that's going to be during 2065. Is that right? During, you see what I'm talking, right? So this is the amount present at 1990. You know? And then you add 75.77. So 1990 plus 75.77. It's going to be 2065 point, 77. Is that right? So which is in during 2065, right? The amount of carbon dioxide will be double the pre-industrial level of 280 ppm. Did you get it, guys? Yes? Yep, look here. Okay. So the continuous compounding, do you know the formula for the continuous compounding? Look here. So the question is this, guys. If you look at the slides, you can see that how long will it take for the money in an account that accrues interest at a rate of 3% compounded continuously to double? Okay? So So how long will it take for the money in an account? How long will it take? So that means T equal to what? Okay? How long will it take for the money in an account that accrues interest rate of 3%? So R equal to what? 3%. So that means 0.03. Compounded continuously to double. Compounded continuously to double. How long does it take, right, for the money in an account with this interest rate compounded continuously to double? So this is the formula, guys, for the continuous compounding, okay? A equal to P e to the power RD. R is the rate of interest. So this is the amount, and this is the what? Initial investment or principal. The money, at the beginning. So you have to find out how long does it take to double this money. So to double this amount, so that means amount will be equal to what? 2 times P. Or you can think like it's the same thing. If you consider that your initial amount is X, so when it double, so it will be 2X. Right? So this is going to be 2X equal to X times e to the power. R is 0.03 times T. R is 0.03. So you need to find out the value of T from here. So if you want to find the value of T from here, you divide both sides by X. You divide both sides by X and you cross them out. So this X cancel. Excuse me. So this is going to be 2 equals to e to the power 0.03 T. This is an exponential equation, right? So you have to take natural log on both sides. ln 2 equals to ln e to the power 0.03 T. Right? So this is ln2 equals to, you see ln e to the power x is x, so this is going to be 0.03t. You know why? Because this is this. So we divide both sides by 0.03. 0.03. You divide this side by 0.03. You cross them out and use this, like use the calculator to get the value of t. So ln2 divided by 0.03. So that's going to be 23.10. We have this t equal to 23.1. So after 23.1 year, your money will be doubled. Make sense, guys? So it will take about 23 years for the amount to be double. So you can write here, it will take about 23 years for the amount to be double. Okay? Make sense? Now look here. So suppose 600 gram, right, of radioactive substance are present initially, and 3 years later only 300 gram remain. Determine the exponential equation that will model this decay. So this is decay because initial amount of 600 gram and the amount after 3 years is 300 gram. So this is initial decay. So you have to find out the model for this one. So the question here is, suppose 600 gram of radioactive substance are present initially. So that means initial amount y sub 0 is 600 gram. And the amount after 3 years is 300 grams. So y3 after 3 years, okay? After 3 years, y3 is 300 gram. So this is 600 gram. This is 300 grams. And you need to find out the exponential equation. So the question is, exponential model is what? Okay? So now remember the exponential model is yt equal to, remember you can write y equal to or y sub 0 e to the power kt. So this is your exponential model. And you know the amount after 3 years. So you know the value of y3, right? So this is y2 equal to this, yt equal to this. But when you plug in 3, so this is y3 is equal to y0 e to the power what? T is 3, right? So after 3 years means t equal to 3. So this is 3k. Okay? So what is the value of y3? 300. What is the initial amount? 600 e to the power 3k. You divide both sides by 600. You divide both sides by 600. You cross them out. So now you will have 300 over 600 is 1/2 equals to a to the power 3k. So that will give you, take a natural log on both sides, so ln 1/2 equals to ln a to the power 3k. Make sense? And you remember one thing, okay? ln 1/2 is same as ln 0.5, right? So this is same as ln 0.5 equals to 3k. Because ln e to the power 3k is 3k. So you divide both sides by 3. So the value of k, because this 3 and 3 cancel, so the value of k is ln 0.5 divided by 3. So ln 0.5 divided by 3 is negative 0.231 if you round to 3 decimal places. Use calculator here, okay? So now you got the value of k and you plug in back here, okay? So you plug in back here. So you have a yt equals to y sub 0. What is y sub 0? Is 300. A to the power k is negative 0.231 t. So this is the model. Make sense, guys? So this is the model. What did I? Maybe I made a. So y sub 0 is not 300, guys. 300 is the after 3 years. This is 300. Yt is 300. No, this is 600. This is the model. Sorry. You see what I mean, right? Because initial y0 is 600 grams. So you plug in y0, okay, 600 e to the power k is negative 0.231 t. Good? So now the part B is how much of the substance will be present after 6 years. So the question is how much of the substance, will be present after 6 years. So you plug in t equal to 6. So if we plug in t equal to 6, so y6 is the amount present after 6 years, right? So 600 e to the power negative 0.231 times 6. So use calculator, okay, to find out this. So times 6, right? So this is y6 equal to 600 e to the power negative 1.386. Right? I got it from here. You know, you multiply negative 0.231 by 6. So now use the calculator to evaluate this. So 600 times So 600 times e to the power negative 1.386 So this is 150.04. Did you get it, guys? So approximately 150 gram of the 50 gram of the substance will remain after 6 years. Make sense? So you can write down, you see 150 gram approximately, right? So you can write down 150 gram of the substance will remain after 6 years. Makes sense, right? So the next one is the, can you read this problem, guys? So example 5. See that? So you need to find out the half-life. I think, yeah, find the half-life of carbon-14. So y sub 0, you see this is the y equal to y sub 0 e to the power negative 0.0001216t, right? So this is, so you need to find out the half-life. So first of all, you see you need to understand the half-life, okay? So if y sub 0 is the initial amount present here, right? So half-life means you need to find the time after which y0 will be 1/2 of y0. You see what I'm talking like? That's the half-life means. So your model is this, okay? So your model is y equal to y sub 0 e to the power negative 160. This is your model, right? And what do you need to find? After, you need to find the half-life. So if you want to find out the half-life, look here. So find the half-life of carbon-14. So half-life is T equal to what? When y will be equal to half of y0. That makes sense? So T equal to what? When y equal to half of y0. So y equal to half of y0 and equal to y sub 0 e to the power negative 0.0001216t. Right? And you divide both sides by y sub 0. So this is gone, right? Cancel, and this is gone. Right? You see that? And then you take natural log on both sides, and that will give you the what? Value of t. You take natural log on both sides, okay? Yeah, I want to stop here, guys. I'll see you next time, okay? On Thursday. Bye.
Do you have to sign in?
I do, but it's